Hi everyone, today we'll be discussing linearity and superposition, which are two very important principles that we use throughout circuit analysis to be able to solve for different currents and voltages as necessary. So our general focus in this chapter will be to look at the principle of superposition and how we can use that to try to solve circuits. We will look at source transformation and how that can be helpful in, again, analyzing circuits. Thevenin and Norton's theorems will be discussed, and they're very, very important, and I would like to bring your attention to them specifically because they are utilized extensively in microelectronics and the next set of courses that you'll be using. And we will then look at examples of the applications of these specific tools that we will learn about. So what does linearity mean? Linearity in a circuit means that a current is changed, or when a current is changed, the voltages will also change proportionally with respect to those currents. What it also means is that if you have a certain number of sources of power, then the overall circuit response is equivalent to the sum of the responses from those individual power sources. Now, the linearity is obviously follows from Ohm's law, and so the resistors specifically follows this guideline. But why is that important is that now we can have the advantage that if we have multiple sources, we could look at the response of the circuit from one of those sources and move on from there. Also, if we see, for example, a certain response or a certain current or a voltage in the circuit, and then we increase the power that is supplied to the circuit through a voltage source or a current source, we can then use that linearity property to determine what the new response would be. We'll solve some problems on this topic and then we'll proceed. But what is very important for us now is to look at the topic of superposition. So we have now come up with the concepts of nodal analysis and mesh analysis, and we can try to solve for different circuit parameters. However, what could be challenging is that as you have more sources, then it can become difficult to sometimes apply these principles. So what we will deal with is the principle of superposition, which states that a voltage across an element in a linear circuit is the algebraic sum of the voltage across that element due to each independent source. So if we have multiple independent voltage or current sources, and we are determining the voltage or current through a given element, then what we could do is we could actually find the voltage and current through that element for every single one of those independent sources and then sum them together, and that would be the response of the whole system to those independent elements. So what you could do now is if you have a circuit that has multiple elements, independent voltage or current sources in there, you can turn some of them off and then you could eliminate them, remove them, and then you could proceed from there to basically solve for the voltages or currents for each single one of them and then proceed from there. So let's look at the steps that we would use to try to perform this operation. So the whole idea is that we're going to apply one independent source at a time. So it's very important for you to be aware of the fact that we are going to look at one independent source at a time. So when we're talking about this fact, it's important to remember that we will leave the dependent sources alone. So those are dependent sources. We will not look into those. They will be left alone. However, we are going to look at independent sources, and we're going to look at them one by one. So the steps are as follows. Turn off all independent sources except one. Find the output voltage or current due to an active source using the techniques that we have covered. So basically use nodal analysis or mesh analysis. Turn off all the other sources, keep one on, perform nodal and mesh analysis, and then find the voltage or current through that element that you would like to repeat this step for all other independent sources one by one, and then when you want to find the final results, just add the contributions of each one of them. So you may ask, what's the purpose of this again? And the advantage is, first of all, you would know the impact of each element or each source of power on your element. So you would actually be able to determine that. Number two is that you can simplify the analysis of a circuit that can seem very complex by eliminating these voltage or current sources. So we'll solve some problem on this and we'll proceed accordingly from there. Thank you very much.